Okay, it is bloody bright and I can't find my sunglasses, they're probably in my car. Going to show you something using old school multimeter. This thing's out about 98 or something, I think I bought it. You've got, the newer ones don't have as many selections and shit like that. We've got amps A, and I've got a 20M over 10 amp. DC, you get your black lead goes into COM, and you have your red lead goes into one that just says 10 amps. It's likely to be a little bit different with the new ones, which are all auto ranging. They don't have a million bloody settings, they work themselves out. But basically, long story short, you turn that on and you whack said leads onto the appropriate positive and negative, black on negative, red on positive for your solar panels, and you do what's called a short circuit current test. Now, I've got two panels on the ground here. Shit, it is hot out here. I don't know how well all this is going to show. I hope there you can see something that says short circuit current bracket ISC 1.24 amp. Basically you'll get this, and hang on a sec, I'm going to set a few things up. Okay, I don't know if you guys can see that, it says 1.11 amp. And if I move it around a bit, it'll change according to the angle that the panel is on. And it may just go blank altogether, because this one does not have the best wire. 1.04, 1.08, 1.9, it's rated at 1.24. I actually got it to go to 1.27. But as you can see, it has a low, there we go, 1.24, 1.25, 6, 7, 8, 9, 1.3 for something that's rated at 1.24, 1.31. That's strange. Something made in China actually performing above its rating. That's shocking. Bloody shocking. Wires on this ain't the best. And that's a long story. Okay, well this one here is the other one that I'm probably going to put in place of where that one there was, because I've got other plans for that one. What do we got here? ISC, short circuit current, we got 1.3, which I hope you can see, but I can't see a damn thing at the moment because of all the reflectivity. Okay, you should be able to see the screen a little bit better there. I'm only getting 0.37 amps, but that's because the clouds are gone over. But this gives you an idea of the way it goes when clouds come over. You know, you have a quite significant drop on something that's rated at 1.3, goes back to 0.37 or 0.38. I might jump to 0.394. Here we go. Now if I change the angle of this, it's likely to change as well. And we're slowly creeping up, uppity it, uppity it up. Boom, boom. Sort of maybe getting there. And here we go, the sun's starting to come out again. And maybe I should fiddle with the angle, but the multimeter will probably fall off. Oh yeah, 1.5 for something that's rated at 1.3. Shit! 1.56. Holy smoke. Well, that's bloody surprising. Usually I can get these within something like 0.02 of an amp of what they're rated at, and then easily enough wiggle around, change my angle just another few degrees, and then bang, it'll hit the rating. I must admit, I haven't got it to go over the rating, and now I just got two in a row to go over the rating. Both this solid one, and the semi-flexible over there. And the semi-flexible is going to be used for another one of my friggin' bizarre things that's already half built, and you guys will see that bizarre thing when the time comes. I still need to buy a little piece and a couple of switches, and then I'll be done, and you'll see that project later. If you can't get anything at all, you could have a wiring problem, or it may even be a problem inside the junction box. Now, it all depends what brand you got. Some you will be able to open. I believe I can't open the big ones on my panels, but those, I'm not too sure, but those brands where you can open the junction boxes on the larger panels, often enough you can slip it open and you'll be able to get in there and resolder, not resolder the wires, but there might be some sort of a funny little clip thing where you can change your wires over, or actually test it right inside the junction box of the multimeter. With these smaller ones, at least in this brand, they put in a rubberized substance. Some brands will be like an epoxy, and it might be like a sort of a honey colour, and you can possibly see through it, which is not uncommon in electronics. Where I worked at the nursery, a lot of electronics were like that. There's quite a lot of the electronics in the Coleman Hot Water On Demand are the same. It's all sunk in epoxy. But this brand, with the smaller ones, they'll sink it in epoxy. And a lot of your larger brands, if you can get your junction box open, they're not sunk in epoxy. And you can literally change incoming wires inside the junction box. And, you know, obviously, if you can get in there, you'll be able to do a current test on it in here instead of at the end of the wires. But if all else fails, you'll see a little thing here, open circuit voltage VOC, which for this one is 21.6. Now the sun's, well, there's a few hours since I've done the other videos and the sun's not that great, and I don't feel like propping everything up while I'm hanging onto a camera, because I could barely manage propping a multimeter over the crook of my knee before. So basically your red lead will go to your volts, which may also have an ohm symbol, which means it's also the same plug you use for resistance test. We go to DC. If you've got auto ranging, you don't need to worry about this baloney, but this one's likely to go to 21.6 volt. Now if I put that at 20 volt, it's just going to come up with like a 1 and a dash or some bullshit, meaning it's basically over the 20 volt. So I've got to flick to 200. Some of these are different for other multimeters. You might have it, you know, different voltage jumps. I think some of them might have an 80 volt, but a lot of the brand new ones that you're liable to get are auto ranging, and all this crap doesn't really matter, because you just got literally one big voltage switch and one big amperage switch. It's, you know, and it works itself out and then displays it appropriately, and they have at least 6 digits, not bloody 3 like this one. But anyway, it's as simple as doing that, and you've got to go for the voltage higher, but we're going to test a 9 volt battery, so we'll flick back to 20 volts. And when I stop fun blasting around here, we'll find that there's 9.32 volts in said little battery. Now, we've got the polarity correct. In other words, the positive and the negative are correct. If I swap those over, it's going to put a little dash on the left there. And when I get my ass sorted out, that little dash will disappear, because I put it back the right way again. Polarity is sort of important. Some things have proof against hooking your panels into the charge controller the wrong way around. Some even have proof against the battery going in the wrong way around. Depends on how good a brand it is and whatnot, but it's just best if you get it right the first time anyway. And I will tell you, with inverters, most inverters, your cheaper ones, you will blow the bejesus out of them. And if you take it back and say, oh, it's fucked, it never worked, they know exactly what's happened. When they know that a certain part has blown, they know you've hooked the positive and negative onto your battery the wrong way for that inverter, and you're liable that they won't give you another one back because it's so commonly done that they know exactly what part blows when you do that. Some of the real good brands have a little fuse inside, and they will blow that fuse, but then you've got to take the charge controller apart and get the appropriate fuse, blah, blah, blah. Inverters are not one you want to hook around the wrong way. But really, you know, how hard is it? You know, negative, positive. If you can't work that out, I don't know how you got your shoelaces done up this morning. But anyway, that's just a little bit more on testing out your solar panels.